Welcome back to Pop Goes the Stack, the show that keeps tabs on emerging tech so you don't have to pretend you read the white paper. I'm Lori MacVittie, and no, I didn't read the footnotes either. No problem. Today's chaos comes from a place we all assumed was safely private, your brain. Because the new user interface isn't even a screen, a keyboard, or your voice. It's neural activity. Once we can map brain signals into language, we're not talking about a nicer input method. We're talking about a completely different relationship between humans and machines. So if you build systems anywhere near this space, here's your early warning. The definition of internal is about to change. Today, we tried to ask someone to test this technology and be a guest, but we couldn't find anyone who thought this was a good idea. So, Joel, I'm afraid it's just you and I today.
Oh my.
That's right. So, look out. Things could get wild.
Oh boy. Plumbing the depths of my brain is not something I expected to do this early in the morning. So, armed myself with a coffee and let's get started.
Let's go. So there is a couple articles about this, and I'm sure, as usual, you've probably at least skimmed them. Right?
I have at least skimmed them. Luckily there's no AI monitoring my brain activity, so you don't know whether I skimmed them or not. So the articles in question that we're talking about, there was an article in the journal Nature and also Science Advances, science.org, that talks about research that's being done into mapping brain activity and the patterns of neural activity in the brain, and trying to apply AI models to it to try to predict the semantic context under which the neural patterns are configured. The idea being that if you are thinking about something to verbalize, that instead of verbalizing it, a scanner can just look at the pattern of activity and can express itself for you in natural language. It's kind of the next frontier of natural language processing. This is not without some background in medical science. I mean, a lot of work is done in trying to trace out the effect of different activity in different areas of the brain. If someone is having a brain tumor removed, oftentimes the surgery will occur while the patient is awake. So they can sample reactions to verbalizations or ask you to do a physical activity. And that way they know with probing activity what areas of the brain belong to that activity. So there is a little bit of background in medical science for this. But I got to tell you, reading the article, this is a different world altogether. This makes a lot of assumptions about brain science that I have tons of questions about. It's kind of scary. What did you think when you read the article?
I thought this is crazy. I mean, I had flashes of all right. And we've all read science fiction. We've seen the movies, right? We know, right? This kind of thing is terrifying, right? It's no, I don't, sometimes I don't want to know what I'm thinking. Like, I don't want anybody, I don't need machines like going, yeah, she's thinking about that. No, please do not share. It seems invasive in a way. It seems very risky. But on the other hand, I've watched things like Neuralink, which exist to help people who they're disabled in some way. They can't move, they can't type, they can't talk, that help them verbalize and communicate with other people. And that's an amazing thing to do. So obviously there are some uses for this that are very good. I'm just not sure that this is ever something we want to put into, I don't know, production.
Neuralink is kind of what I started thinking about. And for those who are listening to the podcast that don't know what that is, that's one of the Elon Musk properties that's experimenting with implants, neural implants that monitor portions of the brain. And they've had some, I don't know if it's necessarily success, but they've had some interesting research outcomes that suggest that people can learn how to activate neural interfaces in such a way that they can express certain thoughts through the neural interface, which is it's a different mechanism than just monitoring general brain activity and figuring out from the pattern of activity what someone intends to say or needs to communicate. This is a completely different thing. It's the
Ah,
same basic science, but one is intrusive and one is designed to be kind of on the side. And again, I have some skepticism here because, like with Neuralink, it's learning over time how to activate the neurons that affect the interface rather than just thinking. And when I think about how I think, my mind is a little bit like an eight-track player, right? I have a lot of different thoughts going on simultaneously. I feel like I have a fairly active subconscious, and medical science and psychological science kind of rationalizes that the subconscious does exist. It does drive some of our activity about what forming opinions and things like that. So which track in that eight track, if you're viewing all your brain activity from remote, which track is this neural model actually modeling? And that's what I find fascinating about this study. It presumes that they can pull out a verbal semantic context, and that's really the only thing that this is interested in doing. I have a feeling there's other semantic contexts in brain activity, and maybe some of it's private. Maybe you don't want people to hear it.
I think that's true for most people, right? We have things we think that we do not share with anyone and do not want to share with anyone, right? Sometimes
Yeah.
intentionally, sometimes things just pop in your head. You're like,
Hmm.
whoa, right? I mean, the notion of intrusive thoughts, right,
Yeah.
exists for a reason because thoughts can be random. But what I like about what you're saying, right, there's a lot of signals going on in your
Right.
brain, and the question is, how does a system like this decide which of those signals are actually the ones that matter to surface them,
Right.
which is a lot like security research, right? You have tons and thousands and millions of signals. How does it know what to go after, right? So, there's some similarities here, at least in how is it deciding what to pay attention to? There's that attention
That's right.
idea again,
That's
right?
right. And maybe it only works on people with one-track minds, in which case it would probably work on hundreds of thousands of teenage boys out there. But I mean, quite frankly, I don't want to be on stage wearing one of these neural caps and ask it to summarize for my audience what I just said and have it tell the audience, I like pizza, I hate conferences, and that guy in the front row has a big nose. I don't want that to happen. So I think that these systems, if they do exist, and if peer research validates that this is something that can be done, I have a feeling these systems are going to need just as many guardrails as other AI systems.
And that's an important point, right? I think some of these systems, most of the conversational AI today has adopted that idea of guardrails, right? Most of us probably heard from our parents, right, when we were young, hey, if you don't have anything nice to say, don't say anything at all, right? That's a guardrail that is put in place, right? Is it kind? Is it helpful? Is it true? We run these kind of guardrails almost instinctively. We don't actively think about it. It just happens because we've learned that. So guardrails are an important part of the human
Yeah.
experience. And so it makes sense to have them on systems. But uh, the, and maybe that's okay, right? The guardrails didn't exist for conversational AI until it was shown, oh yeah, we need those, almost like
Right.
an afterthought. So
Yeah.
maybe it's important for this research to actually figure out, can it do it before it starts putting in guardrails to go, okay, now we know how it works. Now we know how to apply the right guardrails to it.
Right.
You kind of have to know, right, both sides.
The other thing I can't stop thinking about is, what is this technology really intended to be? Like I can see only one practical application of it, and that is for someone who is nonverbal, giving them the ability to communicate in a verbal sense. Dealing with someone who has lost the ability to talk, maybe. But I mean, I read some discussion about this technology, being obviously pointed at the idea that we can instantly and in a hands-free and nonverbal form generate text messages to other people. First of all, I don't know whether that text message would be coming from me or my subconscious. But second of all, is that something that I really prefer over just literally just verbalizing it? I mean, it doesn't seem like it's necessarily going to be any faster. I'm going to have to think it and then I'm going to have to say it. But there's no major increase in speed with which the message is sent. There's a lot of uncertainty around it, and I just don't necessarily know what the practical applications are or the advantages above just pure verbal communication. So I'm confused.
You're confused. I mean, it's cool and it's interesting. And I think there are definitely applications in certain spaces. I think this is a good example of AI and evolution and what it can do that demonstrate it's not always applicable to every task, right? AI is not something you're going to use for everything. This is not something we want SREs to start using. I, people express their frustration, delete everything. Well,
Right.
you thought it, you didn't type,
Yeah.
it's too late, right?
Yeah.
It just basically took everything from root. It's gone.
Yeah.
It's that's not that's just not a good way to do this. And we're still struggling with moving from, typed scripts that are executed by humans to, hey, agents and we don't know how it thinks or chooses or makes
Mhm.
decisions, not really, is going to be executing things. Like, we still have to get there.
Yeah, I definitely don't want this technology connected to agentic structures for a good long while at the very least. The other thing I was thinking about as I was reading this research is it describes a general mechanism for creating semantic context out of patterns of brain activity that are observed. And it struck me that it's all centered around describing what happens with the language centers of the human brain. But then it occurred to me that there are other uh, possessors of brains, and they also have language centers. They may not be the same. Our pets. Is this the mechanism that I finally get to use to understand what's going on in my cat's head when he knocks my water bottle off the shelf? Does he just hate something that sits upright and has to knock it over? I'm curious about that, and perhaps something to apply this technology to would be in greater understanding of the animal kingdom. That would be an interesting area of research.
That would be interesting. I'm not sure. I want to know what my dog is thinking.
Your dog is thinking what all dogs think. Feed me, please.
Yeah,
Pet
right.
me,
Yeah,
please.
yeah, exactly. Yeah, yeah, mine, mine, mine.
Hmm,
Um, but are they thinking right now? You're getting into like the metaphysical, philosophical, realm
absolutely.
of, are they even thinking? Do they? Right?
Yeah.
Is instinct thinking? Is there a difference? I mean, these
Well,
are good things we could learn.
strikingly, this article doesn't make any comparison to neural patterns associated with semantic meaning or thinking. And I think that's a critical distinction. And in fact, it doesn't even assume the brain is thinking. It simply seems it tries to recover information out of the patterns that it observes. It doesn't, all it's trying to do is predict what you are going to say based on your patterns, which is pretty interesting. It doesn't try to really get into the area of thought. So again, that I have a lot of questions about the first of all the veracity of the research. Obviously, there are a lot of people who can publish a lot of things these days. There's a lot of research going on in medical science related to brain activity and the brain, the human brain especially. And so this is really interesting research, but practical applications still kind of escape me. It is fascinating though to see AI, generative AI, and large scale processing, and creating semantic structures in graph form being applied to all sorts of things. This is a really radical one, But I think this is just a harbinger of research to come, frankly.
I agree. I think the bigger lesson from things like this is that everything is changing. AI is changing everything. It is changing how we interface with our systems. It's changing how we operate them, manage them, secure them, how we interpret data, how we do things on a daily basis. It absolutely is changing that. But there are more forward looking, maybe even science fictiony looking uses of AI that are not going to change how you do things today. They're not going to impact your data center in the next 10 years, just
Yeah.
not. And that sometimes we have to recognize that these things, while cool or interesting, and they are fascinating, are not really practical. They can't be applied, and not all AI is really useful for what you're doing.
Yeah.
So we should be able to clearly call that out, to be like, that's not we're not doing that here,
Yeah,
kind of thing.
absolutely. Yeah, I think it's probably decades before we see anything necessarily meaningful coming out of research on this level about brain activity. But in the meantime, no one should be prepared for their CEO, uh, creating a company strategy by mere thought. I think that that's safe to say. It's more likely to tell you that he's thinking about tacos for dinner.
We should just cut it there, because what else, I mean, do we say about this? I think this is interesting, but yeah, I mean, we're just finally getting past GUIs to APIs so that we can get to agents. And this is like 20 steps ahead of that. So, not all the news that you hear about, the great things AI is doing, are real or applicable. And you should probably very carefully evaluate them for practicalness and also blast radius. I
Oh,
think this has
absolutely.
got, yeah, huge blast radius.
Yeah.
So take some of this stuff with a grain of salt, and go back to, how can I apply this to accelerate what I already do, to automate, to be more productive, to find problems faster, and not create problems.
Right, right.
Maybe, right?
Yeah.
Don't go looking for trouble. Oh, yeah. I think that is a wrap for Pop Goes the Stack this week. So hit subscribe so you never have to fake a white paper opinion again. And we'll keep reading the citations. You keep looking brilliant.